webinar. So welcome everyone to the announcement of the 2022 Awards of FME Excellence winners. So my name is François Lagagnère, and I'll be hosting the webinar this afternoon or this morning for the people in the Pacific time zone. Just like last year, like 2022 was a very, very good year in terms of project submission. The Consortech team that was on the jury had to analyze more than 20 projects. The projects, of course, demonstrate creativity and also the vitality of the FME community. And since I was also involved in the selection, I can tell you that although the selection criteria are relatively well defined at the beginning, the variety, sorry about that, and the quality of the projects submitted makes this task of selecting the winners a very, very difficult exercise. Of course, we believe that most importantly, these projects that will be presented today are excellent examples of how technology, of course, primarily FME and RGS, can be used to improve the geospatial performance of an organization. So I hope they will inspire you. So how it will work today, the agenda, we will show, not show, but like the winners of the 3 different categories will present their projects. So the first one that will be starting will be the best automation project. Then it will be followed by the best small efficiency boosting project. And last but not least, the best project outside the box. So the presenter will have access, only the presenter will have access to the microphone. So for the other participants, you'll be able to ask your question via the chat. The presentations are approximately 15 minutes of length, so it will leave some time to ask for a few questions. So I will manage the questions at the end of each presentation. As I mentioned previously, I'm asking all the presenters to turn off their mic once they are done. So the first one, the winner is Public Service and Procurement Canada. The name of the project is National Underground Infrastructure Ticket Management Automation Project. Will be presented by Jean-François Leboeuf and Philippe Palmer. The reason why they won the award, first of all, it is a complete automation project. It involves an important process for the protection of underground infrastructure. That process was previously highly manual and error-prone. So the element that convinced the jury in this case, it was like the diversity of the technologies involved. So FTP sites, FME server, ArcGIS, Gallery app, etc., and the scalability of the solution to handle different input formats. So each one of the one calls has a different format, and there is also an impressive ROI. From what I heard, about 400 hours per year for approximately like 150 hours project, if I'm not mistaken. So Jean-François, Philippe, it's up to you to present. I'll stop my share.
Est-ce que c'est possible? Bon, je vais partager mon écran. I'll share my screen. So just please bear with me.
Yeah.
And I will click on the actual slide, and then there we go.
Okay, I don't see it yet, but it should be coming soon, I believe.
Do you still see mine, or you're no longer seeing mine?
I don't see Philip's screen right now.
Okay, share screen. Share screen. Sorry, my mistake. Got to get used to this. Now you see it.
Yes, we do.
Yeah.
Voila.
It's rather on the small side, Philippe. You can probably, yeah, that's perfect. Great. Good afternoon, everyone. My name is Jean-François Leboeuf. I'm Director of Geomatic Services at PSPC, Public Services in Canada. We're glad to be here today with Philippe and the team, of course, for the presentation reason. A lot of people were involved in this project, but myself and Philippe will be presenting. But really, all my felicitation actually to all the team that participated in this project. And thank you to Consortech to have considered our project. We're really proud of this. Next slide, please. So I just want to take a few minutes actually to give you a bit of the context, and then Philip will go more into the detail of FME, which is why we're over here today. So that government initiative, if I can say, right now it's more a PSPC initiative, but the goal for government of Canada is that protection of underground infrastructure will be in place for all the departments. But PSPC actually initiated this goal by increasing the quality of their underground infrastructure information, geospatial information, and partnering up with provincial notification centers to make sure that we get notification when a dig is being exercised within the vicinity of some of our underground infrastructure. So what's interesting over here is that we are partnering up with the provincial sector because we don't have the infrastructure in place to be notify ourselves of any ground disturbance and prevent all the province actually in Canada does have that infrastructure. So that was quite at start a different scenario where we were not the lead. Actually, we simply hold information and resign on financial departments to give us some help with the protection of our underground infrastructure. So the next slide. So the objective of PSPC, of course, is that, well, we want to protect our underground infrastructure, but we also want eventually to promote our model to other departments. So this is where the information system becomes really interesting, because we are receiving nationally for PSPC many tickets per day, actually, regarding possible ground disturbance located nearby some of our infrastructure. So therefore, having automation that can help, which one of the tickets are urgent, which one are not urgent, which one we can reply with confidence about the information that we have, which one we have less confidence, is really important. And that will bring our model way stronger. So eventually, when we're going to be promoting the model, the PSPC model, to the other departments, it will be recognized and possibly utilized at large. So this really is our goal. So I believe that's enough for the context. Now you understand why we needed FME and for which purpose. And I will let Philip continue with the more technical side about it.
Thank you, Jean-François. And thank you, Consortech, for offering us this opportunity to showcase what we have come up with a solution in order to be able to provide our operational group the tools to be able to manage on a daily basis all these excavation requests that we receive daily and annually, I would say. So what was our challenge? Well, initially everything is done manually. Each request is sent by email to each regional geomatics team via email. So the email contains the actual excavation information, as well as attachments, so PNG, JPEG files that will show a pretty picture of the excavation extent that is being asked for. Then the information is then compared with PSPC internal data, so CAD drawings, plans, and other reference material in order to determine if or not the underground infrastructure is affected. So we don't have any database, and it's just an inventory of emails and attachments that are being used as reference material. So how can we improve this process? Well, before even thinking about a solution, we discovered after discussing with our provincial one-call service centers that another approach could be done in parallel with what we are currently receiving, so the email notification process. The options of sending attribute files such as DBF, XML, GeoJSON, and GML files to a dedicated FTP server. We know that the private sector could offer various types of notification solution, but as a federal organization, maintaining and managing sensitive information such as underground infrastructure, we weren't ready to go that route. So then came the idea. Let's develop our own in-house solution. So using FME, we could build our own custom routine addressing our specific business needs. So a solution that could monitor an FTP server in a near live mode, manipulate new incoming files, and create feature objects such as points and polygons, notify our urgent excavation request, and provide reporting tools. As for the Esri solution, well, we could build our own mapping application to view and edit our data, our edited data, and compare our location-based information with the newly created polygon and point file of the excavation tickets and excavation extent. Now, sending excavation tickets. We agreed with the the provincial one-call service providers to receive an attribute file, the attributes file, in parallel within the minute, and to a new request that was sent via email. So sending an excavation request through PSPC's FTP server is the key of our operation. All provincial one-call service providers send us the excavation via the our PSPC FTP server in an operating matter of a 24/7 service. Now, the automation process. Well, monitoring data creation is based in 3 steps, or in fact, 3 workspaces. Step 1 is retrieving the copied and excavation request and extent file to a data repository on FME server. Once saved, a trigger is set to process step 2 and step 3. Step 2 will consider to do the data manipulation of DBF and XML files to create point features objects, identifying the excavation request with all the attributes, and include as well an emergency notification via email to the operational group, alerting that they have an action is to be taken within the next 4 hours. Step 3 would consider to do the same thing, so it would process a GeoJSON file or a GML file to create a polygon feature object identifying the excavation extent with all its attributes. And all is saved and stored to 2 distinct feature layers. So the automation process. Well, the FTP watch is the sole element of the automation process. The FTP watcher monitors in a more or less live mode, so it's set to an interval of 1 minute to create any new files for the creation of any new files to the FTP server. Once a new file is detected, it's being tested and filtered to the correct file type. A trigger is then set to copy the file to the FTP server directory, so the step 1, followed by step 2 and step 3, depending on the file type. Step 1. So what will step 1 do? Once a new file has been detected by the FTP watch, a trigger is then set to check and filter through the FTP caller transformer. It is then being tested for a specific file extension, DBF in this instance here, and then copied to the FTP server directory. Step 2, the excavation request ticket. Then once a file is being saved and stored by the step 1, we identify and extract all the related attributes of the excavation and request, define the location of the request by a specific PSPC region, specific PSPC region, using a spatial query based on a lat-long coordinate of the ticket. Then we manage the actual time to the request of the request based on a UTC standard and the origin of the ticket. Afterwards, the creation of a point feature is then done with its attributes and saved on an excavation request feature layer. If an emergency notification is detected by an attribute that's being found in the attributes, a notification email is sent to the operational team to be responded. Step 3 is similarly the same thing as step 2. This time, rather than to be dealing with a point file feature, we will define the location once more of the actual ticket, then on create a polygon feature that is being kept once more into a feature layer dedicated for that specific polygon. So what do we get in the end? Well, we get 2 feature layers that hold PSPC's excavation request and extent. One unique source of information, all queryable and editable if needed. This information is the driver to all of our requests, all the requests that are being evaluated. So the web mapping solution, the Esri mapping solution. It's a tool that allows the end user to easily and quickly locate the excavation request that requests attention, standard, as a pink diamond point, or an emergency, a red dot. The excavation extent being the actual green polygon. The PSPC notification areas that are predefined by the business line and provided to the actual one-call provincial call centers. And then on the most essential information, the PSPC location-based information, such as the property boundaries, the building footprints, and the underground infrastructure, and the surface that will and these information is going to be used to review and evaluate the existence of any conflicts between the excavation request and our underground infrastructure. The web map is, so what we see here on the slide is that we can see the actual excavation ticket pop-up table showing the related attributes and the excavation request. All is shown: the ticket request number, the status information, the date of the work, the purpose, the depth of the dig, etc. We also have the excavation extent with its pop-up table as well, showing the related attributes, ticket number, related file names, etc., etc. But the one that is mostly interesting is the impacted underground infrastructure. This is when we can use and assure that the infrastructure is being affected by this request. A quick and easy analysis. All is found in only one simple view. All is available and editable. It can then be searched since all is saved and stored in one single database. No need for CAD files, no need for plans, any other reference material, saving time and money a task that would take in the past 10, 15, 20 minutes now can be viewed and compared easily and simply. Then as I mentioned in the previous slide, all is searchable, meaning that it can also be reported. So using FME server, it has helped us to be able to report on a central space, okay, using the gallery app and web space apps, allowing the end user and senior management to get the better understanding of what we are being asked and to care for. The reports provide stakeholders with the answers that they're looking for. Answers such as periodic reports dealing with the count of tickets during and after working hours at a specific time period. A crucial measure that can have to be dealt with in knowing that the required resource with emergencies occur after working hours. The analytical report dealing with the measure and of each ticket's standard, relocate, validation, emergencies, assessment, etc. It's a specific once more at a specific time period. A report that will provide the extent of the work that has been accomplished during the busy and slower season and other strategic analysis. The reporting of this type of reporting could be done without the help of FME. So what have we accomplished? Well, we've been able to receive and retrieve excavation requests in a live mode. We have transformed and manipulated various file formats. We have centralized our efforts in one national solution. We have answered and replied to excavation requests in an efficient, timely manner. And we can report our work efforts easily. And we can compare our solution with other industry solutions. So what is remaining and what remains to be done? Well, we're ready to push the automation into a higher level. So using the spatial analysis transformer to provide the acknowledgement of potential threat and existing underground infrastructure, and automatically replying through a generic email to the excavation companies. So this is what we are focusing and looking towards our next step into the automation of our solution. So thank you once more for this unique opportunity, and thank you once more, Consortech, for all this recognition, and we're pleased to be here today.
Thank you, Philip. Thank you, Jean-François. It's well-deserved recognition. Interesting project. I don't see any specific question in the chat, and since we are right on time, so I will jump at the next winner. So I'll just share my screen for a minute. So do you see it? Jaco, do you see my screen?
Yep.
Okay, good.
Yeah.
So the winner of the best small efficiency boosting project is the town of Mono. The project is an automatic update of parcel data to RGS online, and the reason why this particular project won over the jury is really because of the ingenuity and the simplicity of the solution. Not saying that it is simple, but it relies solely on desktop and SaaS technologies, and it is highly representative of the reality of many small and medium-sized municipalities. So that was important for the jury to take that into consideration. Also, the other element that tipped the scales was the addition of a mapping component to type of software used by all the local government organization. In this case, it is property and tax management. So, Draco, it's up to you to present.
Thank you, Francois. Just want to verify, can everybody hear me?
Yep.
I guess you can, Francois. Great. Thank you again for the opportunity from you, Francois, to do this presentation. As Francois mentioned, I am Zdravko Jacob from the town of Mono. I'm GIS and IT manager there. And with that hat, I have many tasks. We're a small shop, and we have many users and we have many consumers of GIS and data. So let's start off with. So first of all, for entertainment
sorry,
value, where is Mono?
You're not sharing your screen. Your screen.
Oh. Moment.
I see it is coming.
There we go.
Good.
C'est bon?
Yeah, excellent. C'est très bien.
So where is the town of Mono? Well, you can see it on the map here. We're about an hour north of Toronto. And with respect to Montreal, well, we're probably about 7 hours west of Montreal. So, like I said, we're a small shop. We have a population of just under 10,000. We occupy a large area, though. We're on the order of 278 square kilometers of land. And with that, this is where it starts to make sense. So we're dealing with about 3,779 land parcels. So, and if you want to learn more about Mono, there's a link to find out more about us. With respect to the project specifically, so based on this being about land, our land is managed through property ownership, taxation, water billing, etc., using a piece of software called Keystone. And other municipalities use stuff like Great Plains or VATM for this, like more enterprise solutions for doing this. Those are a lot more expensive solutions. This does the job nicely for our needs, and basically this is what we end up using. So part of the challenge was that the Keystone data ends up getting updated pretty regularly for ownership changes and whatnot. There, as in every area with the prices of real estate, there's a lot of ownership changes happening. So with all that's going on and access to data, how can we get that information to our users more efficiently? So that's part of the key. Keystone uses what they call a TPS file. For those of you who know Office Space, there's a little bit of a chuckle in there for their data management. They're basically tables in a TPS file format. So it's a fairly simple system. Like I said, it's a great piece of software, but it's strictly tabular. There's no mapping component to it whatsoever. So one thing nice about this project is that it opens some eyes up to more mapping use, which is good. And of course, lastly, with the onset of COVID and people working from home, people needed data in their hands more quickly to be able to answer questions from residents and whatnot more easily. So software involved with this project included, of course, the Keystone software, FME, the Esri edition. So we are not running server for this, and we are running a 32-bit version for this. To allow for the connection to the TPS files, we used Soft Velocity's top speed ODBC driver. That is basically just install it on whatever hardware you want to be able to connect to those TPS files and be able to read them, as well as a configuration of Windows ODBC 32-bit version had to be done as well to create a connection to Keystone files doing that. Windows Task Scheduler and Esri, in-house we're using Esri Desktop Advanced, and with the FME component, we needed also the desktop background geoprocessing and ArcGIS Online. So that's what we used. We're not an enterprise shop. So, you know, for those folks who are using Esri and have data in different buckets, there are many options available to you with this. So basically what we had already was we had an ArcGIS model that facilitated this purpose. It would allow for connection to the Keystone, grabbing the data, and brute forcing it into an ArcGIS file-based geodatabase feature class. This process was run by me manually once a week, and even though staff knew that it would happen once a week, we all knew that there was room for improvement, especially again with the COVID scenario and people needing answers quickly. So enter FME into the equation, and where did we go from here? So as an example, here's what the original model looked like. It's a bit ghastly from a standpoint of a GIS model, or GIS model. Basically, a lot of connectors, joins and drops, calculating values, etc., and a sample of what the data looks like as to what we're containing. So each parcel has a roll number and associated information. So, and again, notice that I'm referring to the 3,779 records that we're handling in this project. So what role did FME specifically play in this? So I believe it was basically multifaceted. And first off, basically the model was rebuilt through coaching sessions with Consortech. So there's another thing that maybe you didn't know about Consortech, that they offer training, and they could teach old dogs like me how to use newer technology. So, and I'll admit at first there was some apprehension about learning the software, but if you could do GIS, I think you could do FME. It's very visual and it's very intuitive with its capabilities, and it tells you a lot about your data. Connectivity to Keystone was handled again using the ODBC configurations, and then once we connected to Keystone with FME, we were able to start rebuilding the workspace in the coaching sessions that I had with Consortech staff. As we were going along, of course, imagine this concept, we started finding data issues that weren't prevalent in the ArcGIS model. Like, we didn't see stuff as easily. It started showing that, oh, there's duplicates here, stuff like that. So that formed up a QC component, which was a huge addition and evolution of from the ArcGIS model. So basically, the workbench runs locally on a GIS server. In our case, we have a physical machine that is being used as a GIS server to push to ArcGIS Online. But that's not to say you cannot run this on a robust workstation. So again, sort of a visual of the essential requirements. On the GIS server, we have the server software. So on the server, the top speed driver had to physically live there. The Windows ODBC driver configuration had to happen there. The FME Esri edition needed to be installed. We were running our GIS desktop off of that server, as well as the desktop background geoprocessor. And of course, the Windows Task Scheduler. As far as data connections, so the data connection was set up so the GIS server would pick up the TPS files over the ODBC connection. So what was the essential workflow in FME? With basically using a reader, it would pick up the GIS data from the original feature class as a template, and then it would read in the necessary Keystone TPS tables. From there was basically the transformers. We would do filter, merging, attribute, QC, and email reporting. So there was a lot of work that was done to the data, and a lot more transparency in the data by using FME. And then at the end of it, it had a writer that would dump out to the ArcGIS Online service. So continuing with the workflow, the server process on the server basically we exported a batch file that represented the workbench, made that available as a as an executable or a batch for execution with the task scheduler. So basically, it was those two steps. So everything was built on the GIS server. We generated a batch file from the workbench, and then that was exported, and then it runs as a nightly task on that server. So that's what the workbench ended up looking like. But essentially, I think it's a fair size. There's a fair bit going on there, and this was actually stripped down from what it was before. So how did we benefit, and how were we impacted with this? Basically, this process used to take me from half an hour to 45 minutes to do manually, because I was doing it manually. I'd run the process, let the ArcGIS process run on its own. Done. After that I would publish the two services that we were running as an internal and an external. Performing nightly updates on FME is now just done in one complete step. It's one-stop shopping. Basically, it happens overnight, and there's no real intervention for me unless I receive information about an error. Staff connects now to consume the data through ArcGIS Online services that are available internally. And staff no longer need to, those who didn't typically use, don't have to call somebody about what an ownership was. They can get the updated information from the GIS in ArcGIS Online with confidence. So basically, all this has been made possible, and an easy win for the town with FME and Consortech's help. So summary and conclusions, basically, again, reiterating sort of my title, Keystone plus FME goes right to GIS, which makes life easy for everybody, and we could carry on with other tasks. Like I said, there was a learning curve involved with it, but if you're proficient in GIS, FME is, I think, should become a mandatory thing to pick up. It's so useful. Again, it was accomplished just using ArcGIS Desktop, FME Esri Edition, and ArcGIS Online. Like, we're not using servers, so wasn't a big capital investment. Yeah, as I mentioned, ArcGIS Enterprise and FME Server were not a requirement. A bonus of making Keystone data available for all staff, saving time from people calling each other or asking questions about data, about ownership information, etc. So. The ArcGIS model worked well, but learning the capabilities of what FME provided, it's just not a night and day comparison. And the level of effort to try and do something like that in an ArcGIS model is a lot higher than it is in FME. The tools are right there for you in FME with all the transformers that are available. Benefits of using FME: time savings, error trapping, data transparency, quality control, generating error reports, automation, right to ArcGIS Online. If you haven't gotten an FME, I highly recommend it, basically, at the end of the day. And between that and recommending Consortech's coaching programs, it's a high recommendation from my standpoint. So that pretty much sums up my presentation. So if there's any questions, please feel free to ask. And if you like to, feel free to contact me about this.
Thank you very much. Thank you very much for the presentation. Thank you also for your appreciation of our coaching services. Just to mention that it's not a criteria for the winning project to have been coached by us, but still, like, it's a good thing. And congratulations for your awards. I don't see any questions so far in the chat room. So what I'll do anyways, I'll jump into the winner of the third category, and if like during the presentation or in the meantime, someone has a question for you, I'll make sure to pass it along. So once again, thanks for the presentation. So I'll finish with, as I was saying, last but not least, Can you see my screen now?
Yes.
Good. So the best outside of the box project. So the winner is the city of Longueuil. The project is led the streetlight conversion monitoring project. The project was submitted by François Fillon-Rouillet, and it will be presented by my colleague Victor Soubry. So in this case, like the project, it's funny because like the project, of course, like it is like the best outside of the box project, but the thing is, like the jury members or some of the jury members were seduced by the ingenuity of the solution. Some of them even mentioned that they wouldn't have thought of it themselves at the first place. So that's something interesting. Beyond this, there's a wide variety of technologies that have been used in this project, and also the enrichment of the GIS information. It is something interesting, the near real-time asset monitoring. And so all those things are, in our opinion, like of great interest to the GIS community. So that's why this project has been selected. So enough talking. I'll stop my
share. Guys, do you see my screen? I think start presenting. Is it good?
Yeah, it's good.
All right. So hi everyone. Today I'll be presenting the out-of-box winner for Consortech FME of 2022. I'll be presenting on behalf of the city of Longueuil for François and his team for their work on the LED street lamps conversion that they're doing in the city. So let's start a bit with a few some context with the project. So starting in February of 2022, Longueuil decided to start a massive project to switch their lights from sodium-based to LED-based to have a strategy of more sustainable development. So that first phase of the project cost about $6.5 million to transfer it from the old to the new phase of LED lights. So it rounds up about with 30,000 LED lights that they've been able to implement as of phase one. So why convert to the LED lights? Well, it's first of all, it reduces the consumption drastically from the old lamps to the new ones. So we're talking about a 67% reduction in energy consumption. It's also because it reduces the energy cost. Well, it also reduces the greenhouse gases that it produces. So it's environmentally friendly. It also reduces the amount of maintenance that you need to do to the lamppost regarding the change of the lights. So we're talking about an increase of like, for the LED lights, we're talking about 100,000 hours of autonomy compared to the sodium ones, which were 24,000 hours. So it's a much longer lifespan for the lights. It's also very good for the dark sky compliance. So it's better. It's better for the light pollution going in the sky. It's also, I think it's advantageous for the birds and the flying stuff. I'm not really sure about all the advantages, but it's just a better thing for the environment and the light pollution. It's also way better because it lights up the ground way better, so it's better visibility for the bicycles and people walking on the sidewalks. So it's a better visibility on the ground, but less in the air, so less light pollution, and hopefully we'll see more stars in Longueuil when all this project is finished. So the project description. So their FME was considered as a tool for Longueuil because it was used as an inventory tool. So every light post has a lot of information linked to it. But as before, you had to have someone that was there to collect all the information of the light post that you changed, and you needed to enter all that information by hand, which was very long and not very cost effective. As a new way to do that inventory management, La Ville de Longueuil, City of Longueuil, did use the technique with the QR codes. So basically, they would use a QR code to scan the actual lamp, and then that lamp would be linked with a unique ID, which would be linked further down. I'll explain it later, with the data that's being linked with that unique ID. So it makes it so that you can have multiple teams working simultaneously throughout the territory, and the data is being updated almost in real time with the people managing all that inventory. So it's way faster, but it also makes it so that you can have multiple teams doing so, which is drastically ups the efficiency of that project. Sure, it was very good for that part of efficiency, but of course, with a project of this size, you need to adapt the structure and really, have a good logic behind it to take in all the different structures that need to come in and be unified in main database for the light posts, which was done using FME. So, and also, yes, to include that database that was previously used, you need to adapt every incoming new data to that old database so that it can be integrated. So how it works, it's very simple. So the contractor would go on the field with the new lamp. They just open ArcGIS field maps, and they'd add a new record file for that lamp, and then with their iPad, or I don't know what, I think it's with the iPad, they scan the QR, and then that QR would have that unique ID, and then down the line with the whole FME process, it would integrate the whole data that's linked to that ID, and also that data that was provided by the supplier of lamps. I'll talk about that a little later. So then when we fill out that new file, then the FME server app will be triggered. Either it's automatically triggered every hour, or it can be manually triggered if you change the information for one street lamp. And then when you change that, the whole app will be activated, and the whole process that I'm about to show you is gonna start with the integration of the QR code and lamp. So this is the FME workbench. I'm not going to go too much into detail. I think if you guys have any questions, we'll have a little bit of time after for Francois to answer more technical questions, but I'll go over the main components of how this works and why it's an efficient way to treat the data. So in left, we have the street lamp conversion file. So meaning the QR code that we've scanned has that unique ID. And then we need to decode the QR code. So select a part of it that really puts the unique ID on it. Sorry, I'm distracted. Someone's ringing nonstop at my house. And then, where was I? Yeah, so that the new data that's being reviewed and decoded, the unique ID, is reviewed, and then the extracted Excel files are extracted from that unique ID. Then you need to prepare that data so that it can be integrated down the line with the actual database of the street lamp that's been used for many years now. So we convert that data and mold it so that it's up to date. So we update the data and make sure that there's no change in the database and we're up to date. And there's also another part of that that script that manages the other types of lamps. So there are some cases where, let's say on a highway, there's a lamp that has both directions of a lamp, but it's on only the same pole. So we need to assure that I say we, but they, I didn't do this, but they need to manage the data that is for both lamps, so it's merging the information correctly so that it's identified as just one pole and not two poles. So there's a lot of exceptions that need to be treated. So we prepare the Excel files for each street lamp also, so that it's managed properly. And then for every pole, there's a file that's being linked. So we have a lot more information available outside of the main database, so that we can go specifically on one. So maybe for the insurance, if, for example, there's a deficient pole that needs repairing, and you need specifically the information regarding that pole, and you can go specifically to the file related to it. So next one, actually, this whole process is linked with actually ArcGIS Online, which permits to have real-time visualization, pardon my French, of the whole data in Longueuil. I'll just get out of my PowerPoint for now, and I'll go check out. Let's just see if it works. Hooray! All right, so this is the real-time. Actually, I was talking to François earlier, and he told me that it was updated like every hour, so it should have been updated like 20 minutes ago. So you can see every individual pole that have been changed. So the blue ones are the ones that have been changed. So this one is almost done. We can see that this one, I don't know, probably next. But you can also click on the individual lampadaire, as we say in French, and we can see all the information relating to that specific lampadaire. And then we have the Excel file that is attached with that pole, and we can download it and then go in Excel and go see all the information related to it with the additional information. So this is real time, and it's makes a decision making for these types of huge projects way more intuitive and fun to watch. It's very nice. Good job, guys. Next, okay, so we see this project as being an example of excellence, but of course there's bumps on the roads. And of course, there's always going to be some trouble ahead when you develop a solution as big as this. So there were a little bit of problems with, the contractor that was providing all the lamps. Didn't have initially didn't have the files to give to them, and then when he did, it was a massive amount of data that they give. So with hindsight, with a little bit of hindsight, they think that maybe using API calls for all that information would have been a little bit more efficient, so that there's not as much data in the caches. But then again, it's a very efficient way to do it, but there's still, always a little bit of improvement on the road. And also some of the QR codes that were scanned from the supplier, when they were installed, they didn't have the same structure, so there was like exception cases that you needed to do. But for me, who works with FME every day, it's just a regular, it's an everyday thing, and you're always gonna have an exception. So it's a normal stuff process for these kinds of projects. So as a conclusion, this project is still ongoing. The phase 1 was a success. They've been able to use FME and other tools to make this process very efficient and make the managing of everything as easy as possible. And they're going to continue with that same logic for the phase 2, which are going to convert hopefully all the, I don't know, I'm not sure it's all the lights, but the majority of it. So the City of Longueuil use the QR codes and FME to make this project about changing our environment for a more eco-friendly way. And it's also a project that's very interesting, because I bet a lot of other cities are thinking about these solutions and these transition to more efficient, more eco-friendly way to light and manage our cities. So that'll be it for me. If you guys have any questions regarding this project, there's going to be François, which will be able to answer all the technical stuff. So thank you very much.
Yeah, thank you, Victor. Once again, congratulations, François and the team in Longueuil. I don't see any question in the chat. However, I do have one, for the next steps. So you'll use this process and this technology with the QR code. So what's intended for the next phases?
Like Victor said, the street lights will be changed for almost all the city. All the sodium lamps will be changed. So, like the first slide I think was saying, is that we need to go by phases because there's a lot of street lamps. Um, in total, I think we have like 25,000 street lights. So right now there's 1,300, almost 1,400. So all the sodium lights will be converted to LED lights. Some of them were already converted by new roads, new constructions. So second and maybe third phase will use that technology, and we want to use it for other, not only for streetlights, but for maybe other assets that can have any barcodes or QR codes on them, so it can be implemented so on a lot of things. Right now, we don't have any project like that in the pipeline, but we know that this project opened eyes for a lot of people
Okay,
in our
so it
organization.
is okay. Interesting. So it is for streetlights for now. You see that it will be applied to other municipal assets, but for now, like none have been identified so far.
Not right now, but maybe for park inside parks. It's mobilier in French.
Okay, you can
Like
use the French word.
maybe for other kind of lights, or for games for kids, or for water fountains that has barcodes on it. With the IoT coming in a lot of projects, we will see more of that kind of codes or QR codes installed on assets.
Okay, very interesting.
Thank you.
I don't see other, in fact, I don't see questions. So in this case, what I'll do, I'll first of all congratulate again all the winners. So Public Service Procurement Canada, Town of Mono, and also City of Longueuil. I thank you also, like all the participants, for like watching the webinar today. And we'll see, maybe we'll see also like the winners submitting other projects for the 2023 edition of the Consortech Awards of FME Excellence. So thanks everyone, and have a great rest of your day.